Hello and welcome to the statistics tutorial, another part of this anyway, where we are going to be looking at Excel again, thinking a bit more about data analysis, re-going over some of the ground that we've covered already in terms of descriptive statistics and normality testing, and then looking at how we can carry out t-tests on some data using the Excel function. What we've got here, and this is in conjunction with the shoe sizes data sheet that is also should be up on Wolf, is a load of shoe sizes and the associated gender of that person. This is real world data. We collected it from a cohort of students a year or so ago when we were doing this similar exercise. So this is real world data, so it's just a list of whole shoe size. We didn't bother splitting it into halves or anything, and also the associated gender of that person. Before we do anything in terms of the actual statistical analysis, what we need to think about is the hypothesis, so the question we're going to ask. Essentially what we're looking for is we want to see if there is a difference in shoe size between males and females. Okay, so that's a fairly straightforward question, probably a fairly intuitive answer, but we're going to use statistics to try and give evidence and back up that answer. So in terms of if we're looking at this in a formal hypothesis, something like our alternative hypothesis would be yes, there is a difference in shoe size between males and females. The alternative hypothesis, if you remember, is the opposite of that, so it would be there is no difference in shoe size between males and females. Now, depending on what our p-value is at the end, we're going to accept one of those and reject the other. Okay, so descriptive statistics then. What we've got in terms of our groups here are all mixed up in our males and females. So the first thing we want to do is we want to sort them out into the two discrete groups. Okay, so what I want to use is the sort function on Excel. So I'm going to highlight all of my data here. Okay, my shoe size isn't on here because I'm a bit of a statistical outlier on that front. So I'm going to highlight the data, and then if you go to the Data tab and go to Sort. Okay, there's various options here. We want to sort by column B because column B is the one containing the gender. So column B. Sort on values is fine, so it's going to decide how to sort it, and we're going to do it Z to A, it doesn't really matter, we've only got two genders anyway, so long as we can separate them. Okay, so there you can see we've got our males and females separated, so I'm going to put those separate, so we've got female and male. Okay, I'm just going to copy across these sizes. Okay, it doesn't matter, the sizes don't need to be in any particular order or anything like that. Paste those in, and the same for male. Okay, if you're not at all sure of Excel, you can copy and paste either way. You can go copy and paste using the right click, okay, or you can do the keyboard shortcut, which is Control and C for copy and Control and V for paste. Okay, so we've got those separated out into our males and females. What we then want to do is establish some descriptive statistics, so our mean, standard deviation and reference range. Okay, so we're going to have our mean, we're going to have our standard deviation, and then we'll work out our reference ranges in a minute. Okay, so normally you have a reference range for shoe size, but this just gives you an idea of how it's done. Okay, so our mean, again, we can go in and do this either way. We can use our function key, or we can just type into the cell using the equals to start with to let Excel know using the formula. And if you remember, for mean it is average. So if we start typing, we do average. Okay, select the cells. What we want to do, close brackets and enter. Okay, and the same for standard deviation. For that one, if we remember, was stdev. Again, be careful either don't pick these ones with an A or something. You just want to be standard stdev. And the same, select our column of data. Close brackets and enter. Okay, so that's a mean and standard deviation. Okay, so we're just going to highlight that formula and copy it across. So we've got a mean and standard deviations. Mean female shoe size is just over 5. I'm going to reduce that down a little bit because the decimal points don't really add anything to it, just a point of clarity. I'm just going to reduce that to 1 decimal point, so that's about enough for this, I think. So a mean shoe size is just over 5 for the females, just over 9 for the males. Standard deviations are fairly similar, but as a proportion of the mean, it's actually greater for the females, which is interesting. So they've got a bit more of a spread in their shoe sizes than the males do. Okay, there are a few more females. Okay, so we've got mean standard deviation. From that we want to do our reference ranges. So if our reference ranges, remember, we have 2 components. We have an upper figure and we have a lower. Okay, we can work this out manually. We want Excel, so we may as well ask Excel to help us with it. If we can remember, to work out reference range is your mean plus or minus twice your standard deviation. Okay, so we're going to make a little formula, ask Excel to do that for us. So our mean is going to be the contents of that cell, which is E51. Okay, this is our upper reference range, so it's plus, and I'm going to do twice the standard deviation. Okay, so we need to use brackets to let Excel know which thing we want multiplying by 2. Okay, so I'm going to do 2 multiplied by, so that's a little star key on the number section of the keyboard on the far right, and the contents of cell E52, which is our standard deviation. Okay, again, I'm not typing in the numbers, I'm just using the contents of the cell, because it just means I can then copy across the formula to the next cell. So if I hit the enter key, that will work out my upper reference range for my females. The lower is going to be the same, so equals mean. This time what we're going to do is, instead of plus standard deviation, it's going to be minus 2 times our standard deviation. Okay, so it's lower, take away. And because I use the contents of the cells and not just the number, I can then copy across that formula and it will work out for our males. Again, just for purposes of neatness and consistency, I'm just going to reduce that decimal point down. Okay, so our reference ranges, if you like, so for our females, the sort of reference shoe size, generally you'd expect females, most of them, to have a shoe size between 2.4 and 8, and the males between 6.4 and 12.2. Okay, because we've got quite a small sample here and quite a small standard deviation relative, there's not a huge spread in the data, and they're all whole numbers, so it makes it a bit more straightforward. So I think all of our data points will fall inside what the normal reference range is being calculated to be. Okay, but that's your reference range anyway. The second thing we can do is we can do a histogram to assess the distribution of our data. So this is real world data, and what we're going to do, again, before we do any tests, it's always a good idea to make sure your data is at least approximately normally distributed. Okay. If we were on Prism, we could do one of the normality tests. We're not, we're using Excel today, so what we can do is use a visual approach, and probably the most straightforward way of doing that is doing a histogram. And if you remember the histogram, what you need to do is set up your bin values. Okay, I'm not going to do a fancy histogram, just do a basic to get an idea. With our bin values, because our shoe size is a whole, we'll just use whole shoe sizes. I think our smallest shoe size scanning on the list is about a 3. The largest is about a 12. Okay, so what we need to do is put those in. 3, 4, 5. Oop. Make sure you're typing right. Okay, so those are going to be our bin values. Again, in terms of your histogram, if you remember, you go to your Data tab, go to Data Analysis, providing that's been turned on. Okay, and then on your list you will get histogram. See like that one. Okay, so if you input range, here you can do several things, and I'll show you what we mean. Okay, you could consider putting all your data together, your males and your females, or you could separate it out. Technically, as it's two different groups, you're better off separating it. Okay, so I'll show you what that effect that does. Okay, so we'll do our females first. Okay, so that's our data range. Our bin range, we may as well just use the same. And we'll have a chart output. Okay, I'm not going to bother making this graph fancy or anything, we're just looking at the shape. Okay, so we can see with that, again, roughly looking at the shape of these bars, they are following that normal distribution curve, that sort of bell-shaped curve that we're looking for. Okay, so I would say that looks relatively normal, and I'm happy with that. Okay, so we'll do the same for our male. Okay, instead of our input range being that, I'm going to change it to that. Okay, let's make that a bit bigger. Okay, again with our males, more grouped over to the right this time rather than the left because of the higher shoe sizes, but again they're still following roughly that normal distribution curve. Okay, again, to me, to my eye, that looks fine. What I was talking about earlier, if you had done all this together, so you grouped males and females together, what you get is a histogram that looks like that. Okay, now at first glance that looks a bit less normally distributed. The reason for that is because we've got two groups combined, and essentially we have what you can technically call a biphasic distribution. Okay, so over here on the left you've got all the female data, and that's forming the curve there in these first sort of 4 or 5 bars, and then you've got your male data over on the right hand side, and that's following its normal distribution curve there over on those sort of right hand side 4 or 5 bars. So just be slightly cautious about with your data and what it's going to look like. Okay, doing it separately and doing it together, as long as you can recognise what's happening, I would say yes, those both look kind of normally distributed, and I'd be happy to proceed with a parametric test on that basis. So the parametric test we're going to use to test our hypothesis is going to be a t-test, which is a fairly straightforward test, and it's going to tell us if there is a statistically significant difference between our males and our females. Okay, now there's various different ways we can do that. In Excel, probably the most straightforward way is just clicking a cell, and for preference I tend to use this function button. Okay, you can access t-tests using the data analysis bits and pieces. It's a bit more fiddly doing it that way, to be honest. There's more options and it's a bit more complicated. So I tend to just use the function key. Okay. Happily, t-test comes up in my most recently used list. If it doesn't, you can drop down, and surprisingly enough, it's under statistical, and you can scroll down that list until you find a t-test. Okay, now you get this little pop-up box which gives you some different options. Okay, what we have is what Excel terms arrays. Okay, so you get array 1, array 2, and these are going to be your columns of data that you wish to analyse. Okay, so our array 1 is our female data. Okay, so I'm going to highlight that. That's our female shoe sizes. Our array 2 is our males. Okay, now this is where these options come in that we were talking about in the statistics presentation. Okay, so here we can choose the tails, whether it is a one-tailed or two-tailed distribution. Okay, for this, shoe size could be higher or lower in the males. We're only looking for a difference. So in this case, as it suggests, if you want a one-tailed distribution, enter 1. For two-tailed distribution, enter 2. Okay, we're going to enter 2 because we want 2 most of the time. It's appropriate. Okay, we've got a few more options here. Again, this is where we're going to choose between paired and unpaired. Okay, if we wanted a paired t-test, we would press 1, and there are 2 different varieties of unpaired t-test, which I'll talk about in a second. So if you remember the difference between paired and unpaired, it's all to do with the experimental conditions and the group. Okay, so here we have the same experimental condition. In this case, the measurement of shoe size is the same, but we are comparing 2 different discrete groups, our male and our female. Okay, so experimental condition is the same, 2 different groups. We need an unpaired test. Okay, now the difference between the 2 types of unpaired tests here. Okay, so you have 2 sample equal variance and 2 sample unequal variance. Okay. And that's to do with the number of data points essentially. So here you can see we've got more females than males, so technically we want unequal variance, okay, because the variance is a bit different. Okay, there's more of that. That's the easiest way to think about it. Okay, what you'll see here, it gives you a little preview as your result in this little box here. And I'll explain that in a second. So if we press OK, we get our p-value. Okay, you may be thinking that doesn't look much like a very recognisable number. Okay, what Excel will do, if it is a very, very small number, which it is in this case, okay, it will automatically write it in essentially scientific notation. Okay, so you've got like 9.2532 to the minus 22. Okay, so which essentially means there's you've got about 21 zeros before you eventually reach your point. So that is very significant. If you want to see what that looks like in normal mathematical notation, if I go to that and I change that cell to a number, okay, I'm going to have to increase the decimal points quite a lot here. There we go. Okay, so that is our p-value. 0 point, huge loads of zeros. Okay, so that tells us that there is a extremely statistically significant difference between our male and our female shoe size. And looking at that, that's what you'd expect. Okay, real world stuff with slightly more complicated and fine measurements, I wouldn't expect p-values that small, to be honest. Okay, so what we need to do then is link that back to our hypothesis. Because our p-value is way lower than 0.05, we can say that there is a statistically significant difference between our male and our female shoe sizes, which is our alternative hypothesis. Okay, so we are accepting our alternative and we're rejecting our null hypothesis.